the core of the work we're doing is to generate those cells in vitro and try to use them for replace liver function by transplantation in vivo. Instead of using an anti-organ, we use stem cells so that we don't need an organ. And we generate a lot of those cells in vitro and we transplant them into patients. So that's for acute liver failure. And for more chronic liver disease, we're trying to generate what we call a bioengineered liver, which is like an artificial liver that we built in vitro with the cells we can derive from stem cells, but also working with a bioengineer to find scaffold and matrix where we can embed those cells to create mini organs that we could likely transplant to again help those patients to avoid the liver transplantation. When you want to develop a treatment, you need to understand the organ you want to treat. When you want to generate the cells for cell-based therapy, you need to understand the cell that you want to generate in a dish. And for that, we can only rely on donated organ right now, because that's the only source of cells that we want. Human cells, we want patient cells, we want, that's what we need in the lab to be able to generate those cells from stem cells, because we need a template. And if we don't have this template, we can't work. And the same, if we want to test a therapy, we need to understand the liver itself, and we need to understand human liver. And receiving organ is absolutely essential for that. So one of the great strengths of Addenbrooks actually is that we have a very good connection with the transplant team, because my lab is affiliated to the Department of Surgery, and we can get access to either biopsies or bit of liver that are not used for transplantation, and that make a massive difference. And the system we have put in place, especially with people like Coach Percy, which is a transplant surgeon, are amazing. It's make a massive difference in terms of research and easiness of development. It's really important to underline that, because there's no organ that are wasted, that for sure. Everything used, and it's an incredibly useful tool. It's really accelerating our research. We are collaborating with a number of labs in Cambridge and elsewhere to basically apply the knowledge we have developed on liver and liver cells to other cell type. So we collaborating with, for example, Cedric Gavart in Cambridge with developing blood cells, megakaryocytes for transfusion. We are working with groups on brain to develop neurons, to generate neurons against neurodegenerative disorders. We're working with labs that work on cardiac cells that can then use those cells against heart failure. So we're sharing a lot of information, and the knowledge we have generated the past 20 years on liver cells have been helpful to a lot of other organs. It's a very exciting time. That's the main point. Now, we really at the beginning of a new era in medicine in terms of the type of therapy we can do with stem cells, with CRISPR, with gene therapy, and so on. So it's a very exciting time. There's a lot of work. There's a lot of problem to solve, but we can already see that therapy available in 20 or 30 years will be extremely different from the one we have now.